Well, it is August, and this is the 18th, going on the 19th almost now. Model engineering. A commenter there asked me to deal with model engineering, and before I go any further, realise this is not for everyone. Please don't watch all this unless you have some interest in that. I am very creative in many ways, and I love using tools, but I do other stuff like a bit of painting and all that sort of stuff, watercolors and that. So people like to make things. Men tend to be a bit more into it than women. I'd say a lot more, but there are women doing jewellery and using acetylene torches and everything. So we don't have the sole preserve of it. I don't. It's a subject that's difficult to deal with, for the simple reason that you could be recommending people spend a lot of money on equipment and then they mightn't use it, and you mightn't have the time. And certainly, if there's anyone watching this 23 or 4, and you have an inclination that to definitely invest for your life for a good lathe, a good quality lathe. Maybe a 3-foot one would be ideal. There's a Grizzly make, I think, and there's a few like that, but they're nearly all driven out of Europe. Long ago, there was Boxfords, they're gone. There was Myfords, they're gone in Britain. There was Atlas in America, all gone. China nearly has the whole market taken over. My own lathe is Taiwanese, and it's a rattly old machine, but very accurate and very well made. I wouldn't swap it. You won't get one now. It's a Shenhua 900B. There's a few things to look for in them. Now, could you get along without a lathe? Don't confuse a wood lathe with a metal lathe. They're two totally different things. If a wood lathe lets you out for making dolls' houses and turning wood, that's all right, surely. I have no interest much in that. The first thing to remember that the English were to the forefront, and you see people there making anti-English comments and all that. The Englishmen were great at that, and I go over to model engineering exhibitions. This idea of oh, he's a West Brit, it's baloney. But the thing about it is that there were several great suppliers of all the stuff. There's only a few left. Blackgate's Engineering, Shamos and Reeves are the ones I deal with. And one of the things is it involves usually making steam engines or hot air engines or something else. And they make castings. So many of the suppliers will have casting house where they melt steel, usually mild steel, and pour it into molds, and every 1 in 10 is defective, but we'll say 8 in 10 is good. And then you can buy them, you can buy the casting, and you'll get a set of drawings then, and off you go. Now, some people are not good at reading drawings, and you could be a long time. You could be a long time making something. And meanwhile, there's other stuff to be done. And what you would find if you had the equipment and a reasonably good workshop, even a garage. I operated out of a garage in a semi-detached house for a long time. I had enough room. It was tight, but there was enough room. There was no windows, but I had good lighting. But anyway, you'll find you'll be doing all sorts of stuff. You'd never realise how this equipment is so useful until you have it. I mean, I put handles and saucepans and everything. Great job, yeah. Now, you get your castings. If you don't use castings, you have to fabricate. You have to get a round piece of steel, and you have to part it off, and there's a lot of work to it, and you have to make, we'd say, a wheel for a train. We'd say a wheel for a locomotive, a steam locomotive. You have to turn it out of a piece of stock. And there's plenty of work to that. Not as good as the castings. The castings will still have the track of the forging, the casting on it. Now, forging is another way of making parts. And that's where you have a big hammer and the hot piece is left on a die, and the hammer whacks, gives it a whack and turns it into shape. And that's superior to casting. A cast part, the steel runs out and it's just like you'd melt lead and pour it into a mold. The forging, the steel is shaped. It's forced around the corners, and the grain is set in a way that makes it very, very strong and good. I don't think there's any of that hammer forging stuff available, and it's not something you'll be able to do. You probably won't be able to have a little furnace either to cast stuff. You probably won't in a cupola. You can buy them and all. It's a lot of work. I don't do it. I did it a few times, but it's a lot of work. It's probably out of your depth. So then when you look at some of the companies, you'll see the model steam engine kits and all, and then are you up to reading drawings and all that? No, it's difficult enough. Now, for those who want to just get a foot in the door, there is Stuart Turner. I must just see how they're still on the go. So it says here, Stuart Turner was a British engineer who founded a company in 1906 to make models and pumps. So right, to make model steam engines and pumps. So before World War One, he was in production in Hanley-on-Thames, and they're still there as far as I know. And you can get. He had all sorts of stuff, including two-stroke engines, and all of this. Now, as far as I can see, Stuart Turner is still about making stationary steam engines and petrol and hot bulb engines and different type of engines, as far as I can see. And I have an S50, just a simple S50 stationary engine. There's one I particularly like, is a low pressure Victoria, and there's a twin cylinder Victoria mill engine. It'll drive perhaps a very, very small dynamo. They'll generally produce a little bit of light. I might do a program on one. You need a boiler then. I bought a Babcock boiler, and you need a boiler too. Don't try running them off a pressure cooker. They will run off a pressure cooker, but not recommended. You don't have the right safety. So that's one way of getting in on them, looking at that Stuart Turner and seeing the various models and all of that, and buying them and mounting them on a board, and you can have your little working model steam engine there and put it driving something, and they're nice little things, all right. These are not now traction engines for like tractors or railway models. They're railway engines. They're just stationary engines. I'll just see, can I find one here? Now you can run them off compressed air quite safely. Now there's the S10. That's the Stuart Turner number 10V. There it's there. That's a typical one. You get the castings off them from that, and you can make it yourself. And if you're not just up to it, you could, if you could afford it, buy the engine itself, and then maybe you could get a bigger one. And using what you see and how these work, you could then set about building a better model and a bigger model using their castings, which are top quality. So here's a 5A single cylinder steam engine. You get it there if you just Google the various Stuart Turner models. So I think, having thought about it on only 8 minutes, I think for the model engineer or somebody starting off, you can get the machined and all and assemble them yourself. You don't have to go anything too big. You need a boiler. A lathe is not needed to make a boiler. You can make boilers. I have a book somewhere on model boilers and boiler making, but they're supposed to be proofed and tested. You can buy them already made. If you do buy them, make sure, if you're not using them, drain out all the water out of them. And they're better filled with, I'll not tell you now what to fill them. There is special stuff to put in them. You get special stuff for the water, but I think if you drain them out and put some type of, probably paraffin might be a good thing in them. Ordinary paraffin might smell a bit when you get it done, but you can drain it out after. But if you leave them with the water in them, impurities in the water will dissolve the silver solder joints, and you have a problem then. So yeah, look it up there. Stuart models might be the way to go for model engineering. As for buying lathes, yeah, if you got a new Chinese lathe, there's Grizzly is a new one that's coming on the scene, and they seem to be nearly a carbon copy of my own Shenhua. They're either made in China or Taiwan or a copy of both. There's Best Equipped Metal Lathe 7x14. There's Shop Fox M1015. There's Grizzly G8688. Grizzly is a Chinese job. Not too bad to make either. Erie Tools, Eastwood, Best Equipped Lathe, and Tenga Gula. There's all these makes on here. Now, there is Warco, who advertised in the model engineering books for years and years and years. And I would say they would be very good quality. They're marketed in the UK by Warren Machine Tools, Unit 1, Fisher Lane, Chiddingfold, GAU84TD. They're a long time on the go. I would imagine a Warco lathe would be quite good. Now, I'm just picking a bench lathe. The bench lathe has one with no undercarriage. You can put it on a bench. You don't really need a bench as such. Very heavy lathes come with you couldn't put them anywhere, only on their own base and all of that. But I'm just looking at one here on Warco now. It's a WM80 lathe, and it's 1,265 pounds sterling. It doesn't say if the VAT's in there. I don't think that's. No, I don't think that includes. I think VAT's included. I'd say that's the price. Now, if you're buying one of them, or even something a little bigger, that's not that big of money. We just see what detail there is of it. Now, it is a brushless motor. Yeah, they say they're great. I don't know. Must be. I just have a split phase induction motor, 230 volts. 2 speed bands allowing minimal torque at lower speeds. That's probably good, all right. The trouble is, if anything goes wrong with them. Infinitely variable, 50 to 3,000 revs per minute. Yeah, that's the new ones are like that. Now, I go back to say Warco is a long time advertising in the engineering press in Britain, and they're a good company. Those people that do it there, and they have their own website. You know, it's there again. Warco sale. You know, they're a long time around. Now, I know they're all made in China, but I'd imagine Warco would be have some wee bit of it wouldn't be just a complete fly-by-night job there, I'd imagine. And so we'll go on to their. Now, it is a double V bedway, hardened and ground. That's what you want. It's hard to beat the hardened and ground V bedway. The Myford lathe just had 2 flat beds and they weren't hardened at all. So hardened and ground. So that's good. Adjustable jibs and slideways. That means that the jibs that slide, the slides have jibs that's adjustable. That's very important. Offset facility for tailstock. That means you can push the tailstock over and back. That means you can turn tapers on it. A very important feature too. A reversible motor. Well, that's vitally important. There's times you will want to reverse the motor, and that's important. If you're only drilling and the drill sticks somewhere in it, you need to be able to go reverse. Metric and imperial thread cutting. Yes, it has a change wheel which has 120 cogs on one side and 127 on the other, and because the inch is 25.4 millimeters, you can cut both threads from an imperial lead screw. It's probably something like 8 TPI or a little less, maybe 12. Metric. Now, zero friction dials. Well, that's what they say. I never had a problem with any of that. Steel gears. Yeah, no plastic. A lot of them are plastic, the gears. You're better off with steel. Powerful 550 watt motor, which is adequate, and steel gears is in twice. So that is standard equipment. It would come with a swarf tray, so that's a tray to catch the swarf underneath. Rear splash guard, good idea. A faceplate, vital. A faceplate is a vital bit of a component. You'll get them there if you look them up. 3-jaw, 100mm self-centering chuck with inside and outside jaws. That's the job. 4-jaw independent chuck, very important. You won't use it near as often as the 3-jaw chuck, but a great job. Fixed steady, that keeps the work. If it's a long bar, it stops it from moving. A fixed steady. A travelling steady, that's the one that travels on the saddle. 2 dead centers, 2 marsh taper. So the marsh taper obviously at the tailstock is 2, and 3 marsh taper at the headstock, ideal. Compound slide, that means you can turn the compound slide over and back. You want to cut a taper around. You can thread it round like a what do you call 360 degrees protractor. Yeah. Thread dial indicator. It takes a while to learn how to use them. It's not essential, but it's a nice thing to have. And toolbox and maintenance tools. So the machine number is 3200 320B. Its width is it's 60 kilos. Like you could go bigger. 60 kilos is not that heavy. You could go one of the bigger models. Length is 840 by 440 by 270 in height. Tray length. Now that's the size of it. Shipping dimensions 810 by 465. So that's all right. Motor size 5.5 horsepower. Power transfer gearbox variable speed. Spindle speeds, it gives you them there. You have a wide variety of spindle speeds. Voltage is 240, that's what you want. You can get single or three phase. Make sure if you've only single phase, you only get single phase, otherwise you'll be stuck. Filament plug connection type, wouldn't worry about that. Current 50 hertz, that's our own one. Maximum swing is 180 millimeters. That's the total swing. So that'll be half. So it'll be 90 millimeters would be the height of the spindle above the bed. So center height 90 millimeters. So that's plenty, 90 millimeters. So that's four and a half inches. You wouldn't want any more. Distance between centers 300 millimeters. So that's a foot. It's not that big. That's what I'm saying. You might even be able to go a bit older. I think if I was recommending to any lad getting one, especially a fella that wouldn't be maybe still midlife or that, you go as big a workout as you could get, I'd say, would be the best advice. Longitudinal travel 190 190 mil. So that's the distance the you can travel up and down, 190 millimeters. Cross slide travel is 90. That's the distance you can go over and back. Top slide travel 85 millimeters. Spindle taper, 3 marsh taper ideal. Tailstock taper, 2 marsh taper ideal. Tailstock quill travel 60 millimeter ideal. Spindle bore 21. So that means you can only get 21 millimeter diameter steel or a bit less work through the spindle. Like you're going to stick it right through and out through the chuck. But still you have 3/4 of an inch there. It's not too bad. Tool shank size 12 millimeter. That's all right. Metric and imperial threads, great. Chuck mount, flange fitting. Yeah, I want to watch to see how some kind of a flange fitting that you don't have to jam the spindle to get them off, and I have to bend mind you. How do you hold the spindle going around when you screw off the chuck? I'd say they have some other type. The bearings are taper roller and this belt drive, and that's good. Taper rolling bearings are what you want. If you buy a used Myford, they're a solid shell bearing, bronze bearing. They need constant oiling, and I wouldn't have without taper roller bearings, and a belt drive is ideal too. Country of origin, China. Approximate assembly setup time 30 minutes. CE approved. Yes, available on request. Optional stand, you can get a stand for it. You can get a scale, you can get, of course, chuck mount sizes. I'm not going into that, base tray and all that. So look at buying a Warco, that very versatile lathe, offering precision, robustness. I'd say they're a good lathe. The model engineering crowd wouldn't be having them advertising if there wasn't something good about them. So I think the one of the problems, if you want to set the protractor, you have to pull the top slide back, really back, and then to get at the 2 bolts underneath. I think anyone that wants it for a hobby will have a few minutes extra. Speed is not the thing. Speed is not everything in a hobby like model engineering or anything else. So I would be looking at, and I'm not taking responsibility for any of this, I hope you don't hurt yourself or anything, I would be looking at the biggest Warco lathe my pocketbook or my wallet would allow. If you could get a 2-foot one, So I'm just looking at one here that's 2895 including VAT. VAT seems to be in it. It's 250 volt, it appears to be. It's all right. We'll just go through it here. What the make of this one is. It's the WM 250V variable speed lathe with DRO AC motor invert drive. A lot of things there. I'm not going into it too much, but we'll just look at the features of it. It has all the double V bedway, hardened and ground, very important. Adjustable jibs and slide, very important. It's on a lot of them anyway. Tailstock quill and metric is metric and imperial. Reversible motor, that's important. Extremely quiet. Metric and imperial thread cutting, reversible lead screw for left hand threading. Yeah, you could want to cut a left hand threading. You need it. That's an important thing. A reversible lead screw means you can cut the thread the other way in reverse. If you don't have that, you can't do that. My lathe has that. So it has down to 30 revs per minute, and then it's away up to high speeds. We'll see what the speed is here again. 220 revs per minute. That's plenty. Now, we just see now, it has a swerve tray, a splashback, a faceplate, a 3-jaw chuck, a 4-jaw chuck, a fixed steady, a travelling steady, 2 dead centres, tread dial indicator, toolbox with tools, safe interlock chuck guard. I presume that's a way, I'll just look at it here now. The only thing I'm not sure is how you get the chuck off. That's important to know. I presume it's not just a screw off. We might find out more, and I'll post underneath. So we just look at the size of the specification. Center height is 125. Maximum swing is 250. Swing over cross. Distance between centers 555. So that's half a meter. That's more than half a meter. So a foot is 33 centimeters, isn't it? So this is 55 centimeters. So a foot would be that height. So this would be about this. That's a nice lathe now there. And spindle taper, 4-marsh taper, grand. Spindle bore, 26. You get a piece of work 26 into it. The hole in the spindle is 26. That's good. That's generous. That's very good. 2-marsh taper in the tailstock. That's the same as mine. That's perfect. Chuck mounting, flange plate, motor, 1.1 kilowatt. That's a good motor there. Power supply 240 volts. That's our own. And weight, it's 125 kilos. So it's a high quality, to say here, the wood, a very accurate machine. But that would be a bit over time now. That would be an excellent lathe. That's a Warco WM 250V. That would be my choice if I were going one. We just see what weight it is here. Just stop this here. Yeah, it's 125 kilos, 2.5 bags of coal. Wouldn't that be the weight? I think so. A little bench machine. That would be a very nice machine to have if you're thinking of buying. I'm looking at work in the books. I buy the model engineering and the engineering in miniature now and again, and you get it in the country. Only I think there's some EU law it can only sell it in Dublin. I don't know, but they're advertised there for years. They are a Chinese lathe, but they're supplied through Britain, and I'd say there'll be never any problem with parts for them or anything else, and that'd be where I'd be looking for a lathe, is Warco. There are others. The Emco lathe now is not the original Emco lathe. The original Emco lathe was made in Austria, and they were good quality, but they were a bit light, but they were good quality, very accurate for light work, but they're not making them there anymore. So I think that's terrible. Like the Chinese one is called Emco as well, but it is not the same as the Austrian lathe. A good second-hand Emco would be a good lathe too. But sure, Colchester Student, if you could get it, would be all right. So